Hello, folks. I'm here to talk to you about how AlmaLinux loves NVIDIA somehow. Powerfully pushing pixels easily. It's early in the morning. So this is a little bit about me. I'm not going to read off the whole thing, but there's a glance of like my experience and expertise and all that other fun stuff. You can see I contributed Fedora, AlmaLinux, CentOS, OpenSUSE, and I'm in a number of leadership positions. As Benny mentioned earlier, I'm on Alesco. I contribute to a lot of stuff. I'm a principal consultant with my company, Velocity Limitless, and I also am a co-host on a podcast called The Pseudo Show, where we talk about the business of open source. Check it out at some point. I think it's fun. And I also contribute to Katie quite a lot, because Katie is the best. So let's talk about NVIDIA and Linux. So it's been pretty well known for a long time that NVIDIA creates a ton of issues for Linux users. You tend to see people asking on forums and places like that about how, okay, we're trying to install the NVIDIA driver, can't get it to work, or like my laptop can't switch to it, or I can't get or like the most bizarre one is that sound stops working. Like, I don't know how graphics affects sound, but here you go. And like, this is just kind of a sample from the AlmaLinux forum of like 3 separate ones of these, but you go into Fedora, you go to OpenSUSE, you go anywhere, and you'll see people complaining over and over and over about how difficult it is to get NVIDIA hardware to do the right thing on Linux systems because NVIDIA doesn't support an in-tree driver that is integrated with the standard Linux system like all the other vendors do. So for NVIDIA, as of currently, that's not really a thing. For a long time, this was just something that people kind of had to deal with. And it was really bad for us when Jonathan and I were at Scale. Jonathan Wright is, again, another member of Alesco, but also works on AlmaLinux infrastructure. We were at Scale earlier this year, and we had this cool System 76 Thelio Astra. It was a very powerful, super special ARM-based workstation that had an NVIDIA GPU in it. And it had no integrated Mali GPU in the SoC, so there was no onboard graphics to fall back to. And and this card was special. It wasn't supported by Nouveau, so there was no fallback, nothing worked, and we had to do some weird stuff to try to get to a point where we could install drivers and get things working. And you can see, like on the left, the screenshot of, well, we tried and it couldn't open the graphics, and so everything was crashing all the time. So we spent a couple of days, actually, like legitimately a couple of days, actually putting this together and getting the system up and running. And we weren't the only ones at Scale who was given a machine to get set up and demo their stuff on, because ARM had partnered with System 76 to bring it out for a bunch of the distro booths to have this system up and to show off their wares using this system, because it was, in theory, a system-ready SR system with full UEFI ACPI, basically a bog standard system. It looks like a regular PC, except for it doesn't use x86. So it should be easy. And it turned out to be a very difficult proposition, basically because of this weird NVIDIA card that was in here. So that took us those couple of days, but we wound up being basically the only group that got everything working. Because between Jonathan and I and our years of experience futzing around with things in computers, we were able to manually get the driver built, linked, and running with some glitches here and there, but it was actually functioning to the point that we could actually use the machine as part of our booth demo. So this kind of made me think about, we need to solve this problem for AlmaLinux, because NVIDIA makes up, I don't know what, like 80+% of the laptop market and more than 2/3 of the desktop market, and it's like nearly 100% of the enthusiast space, regardless of form factor. So solving the problem for AlmaLinux required figuring out what we can do to solve this. And Jonathan and I put together an RFC shortly after this, and we submitted it to Alesco, the AlmaLinux Engineering Steering Committee, to build the open source drivers and to ship a repo config for the user space parts in AlmaLinux. And this was approved by Alesco, I don't know, like 2 weeks after we submitted this. And when we started working on this, we had to build a bunch of infrastructure about figuring out how to do the signing workflows, and there were a bunch of bugs that needed to be fixed in how packaging kernel modules work, because it turns out not many people do it, and so the infrastructure had gotten a little bit weak. And we started working with some of the folks in the community that happen to work at NVIDIA to understand the pieces between the user space and the kernel space and make sure that we get our parts right so that those all slot in. This kind of timed out well, like the EL10 release that happened at the end of May allowed us to get a better picture of this stuff. And it took a little bit for us to get there. But we did manage to do it and have these NVIDIA drivers in place. So we have these packages that are now available that provide the kernel module. Now, something that we've done a little differently compared to most is we have built it for all the supported kernel flavors that exist in AlmaLinux for x86 and ARM that the NVIDIA driver modules were compatible with. So that means that if you're running a standard x86 system and you're not doing real-time, then you can, the non-real-time kernel flavor works fine, the standard kernel flavor. The NVIDIA driver doesn't support real-time kernels, so if you're doing stuff with kernel RT, which is the preempt RT patch set, that doesn't work. It doesn't build against it. But it does work for the standard stuff, and in particularly in VFX or in post-production and things like that, this'll be fine. Now, ARM is where things get interesting. So it's not just that we support the standard ARM kernel that we have. So in AlmaLinux, we have 2 kernel variants that we provide. The standard one and something called kernel 64K. And this is an environment where if you have particular types of workloads like databases or SAP or any of these other weird things that are like require lots and lots of in-memory commit, like they write stuff into memory and then they flush it to disk later, and they want to have large allocations that are fast. The kernel 64K uses 64K page sizes, which is different from the standard one of 4K page sizes, and a little bit technical, but basically it boils down to you can allocate bigger chunks of memory at a time without as much of a performance penalty. And so for things that need that, which is notably a lot of AI/ML workloads, a lot of database workloads, things like that tend to require that. To the best of my knowledge, we are the only ones that offer both for the driver. So like you are able to use it with either one of these when you set it up on an ARM system, and it should work great. And the end result of that is we have these working things. So Jonathan and I did it at the AlmaLinux, and you can see there's machines and stuff there that actually have all the machines that were there all had NVIDIA cards, and we were able to get everything working with it. So with the setup, like you can transparently be able to use anything that is supported from GTX 1650 or RTX 20 onward, so touring and newer. This is reliant on the NVIDIA GSP firmware and the rework that they've done for the GPU open driver. So if you're familiar with NVIDIA having this recent announcement like a couple years back about switching to these new driver types, we're dependent on these new drivers. Now, this is also important to note that this driver set that we've shipped supports the new RTX 50 series GPUs and everything that's built on the Blackwell GPU architecture. And everything from Blackwell onward will only be supported with these types of drivers, not the other type of NVIDIA drivers that they have. And I realize that's confusing, but basically what we offer supports all the stuff that NVIDIA currently supports, markets, and sells. So if you need stuff that's older than that, Nouveau is probably your best bet, and that sort of thing. So this is about the present. We have all this stuff working, but what does this mean for how things are going to go for NVIDIA in AlmaLinux, or really in Linux in general? there's a new driver coming into existence in upstream Linux. It's not available in AlmaLinux or really any distro yet because it actually doesn't do anything yet. But this new driver is called Nova. It is being developed in by Red Hat in partnership with NVIDIA. And this new driver is one of the first graphics drivers being written in the Rust programming language that's landing into the Linux kernel. And this thing is supposed to supersede both Nouveau and GPU Open. The idea is that there will eventually be this one unified in-tree kernel driver, and you will be able to use the open source user space with things like NVK from Mesa with the open source Vulkan, or you'll also be able to use CUDA libraries from the proprietary user space that NVIDIA offers to you. And it will be seamless in the long haul. Right now, we're nowhere near that. It's going to be a couple of years before this is ready for people to use. But in the long term, we're probably not going to have this having to deal with different GPUs, different GPU drivers for different classes of the NVIDIA stuff, because all of this will be unified. And every NVIDIA card is going to use GSP firmware going forward. If you're familiar with how the AMD graphics cards are supported, this is basically going to put us in the same bucket as AMD graphics cards. So while things are a little on the sketch side when it comes to like how do you put everything together, it is going to get better. But even with the current situation, later today, Jonathan and I will have our workshop where we're going to show off how you can have internal deployments and mass deployments set up, customized to have all the stuff we've done put together so that everything just works out of the box when you're putting it on like workstations or servers or cloud machines or whatever. So that's kind of where we're going with all this long-term Nova. For now, we have this repo with the stuff, and we'll do our best to be able to support all the architectures and platforms and use cases that are available to us. So this is pretty much it. I'm open to questions or any of the sort. Yeah, you?
So it's a little bit devil's advocate.
Sure.
Because it's mirroring complaints that I've heard about the driver. So my background is working with effects and video game and animation space. Drivers become a little bit of a black magic in some cases. I've seen situations that don't make any sense at all, where you've got version X of the driver, you've got version Y of the driver, and they're producing different results. And that means that there's sort of a cargo cult mentality that you encounter where people are very concerned about altering that part of the pipeline. So I'm curious, when you talk about compatibility, you talk about glitches, has that been tested in terms of render farms and producing the same output? Even though it doesn't make any sense and it doesn't actually follow any logic, I've seen it happen in the field.
Sure. So there's a couple. So the question is, has this been tested with render farms or large distributed workloads? I'm summarizing your question. Hopefully, I get the gist of it. The idea is that has this been tested out at scale of any kind? We had just formally launched this last week. We have been soak testing it with a subset of people for about a month or so. And in doing so, we've been iterating and getting feedback from different people to make adjustments and fix things. There's actually a bunch of bugs that were found very early on that I wound up having to fix, or that we wound up having to deal with, were a result of some early testing. Now, I hadn't particularly observed strange performance deltas from version to version or any of that sort of thing. I don't think anyone reported that. They tended to see, yeah, everything is consistently working, that sort of thing. But I want to address the point about the cargo culting about having to have specific versions and lockstep and stuff. You might have noticed that I only am shipping the latest code stream for the NVIDIA driver in here. This is because shipping multiple code streams is a pain, and getting the user space and the kernel space stuff to all agree, and to make sure people don't mess up when they install it, which causes a good portion of bugs. And I suspect a lot of this mentality about having these fixed version stuff is because people don't know how to upgrade everything correctly in lockstep. One of the reasons you might see stuff like this is that specifically with the NVIDIA driver stack, the user space and the kernel driver are not API stable between each other. So they have to move in lockstep. And what sometimes happens is that somebody will update the user space without updating the driver, or they'll update to a new kernel, the new kernel doesn't boot, so they boot back to the old one. They don't realize that the old kernel has the older driver, but the newer user space, and so things break down. So the philosophy I'm going with for now is that until something really forces us to change anything, we're following the latest code stream, and we're basically saying we support the latest code stream and we're following it and moving in lockstep with that. And this simplifies the support matrix. It kind of eliminates most of the concerns that people wind up having about performance and reliability and that sort of thing. That being said, your mileage may vary. Test your workload. Make sure you understand the characteristics of your workload, because you'd be surprised how much of this stuff that people cargo cult and think it's about kernels, but it's actually about user space stuff. In graphics particularly, most of the API domain stuff is actually in user space, and then the processing is then sent to a dumb pipe in kernel space and then forwarded onto the GPU. This is how it works for AMD, and now this is how it works for NVIDIA. So the user space has more of an impact than kernel space does. And funny anecdote here, when we first got the driver working, I refused to use it with the user space because I wanted to make sure the driver itself worked. It works without the user space, but it moves at a pokey 5 frames per second. It is extremely slow when you use the Mesa stack, because it will just use LLVM pipe, and then LLVM pipe isn't actually compatible with the NVIDIA kernel module, and so like it freaks out a little, and yeah, so it's very, very slow when you do it that way. But it does work. So this is also kind of like what I'm saying, is that the user space part of the driver actually has way more of an impact than the kernel space part does. My hope is that when we go into the Nova future, then the API between the two will be stabilized, because that's part of the Linux kernel policy. And a lot of these troubles can go away, and then people can like figure out the user space workloads, and they can kind of pin down where regressions start occurring. They can work with NVIDIA or Mesa or whoever is the vendor of the stack that they're using in user space to improve things. Sorry, that was a bit detailed, but hopefully it answers.
Yeah, absolutely. Do you mind a second question?
Sure, go for it.
We've got a mic for questions
yeah.
now.
Good. Mic for question means I don't have to repeat it.
Hi there. So the second question I've got is to do with like VDI pass-through. When you're using something like an A6000 or something like that to split cards apart. Have you played around with that at all, or what's your mileage on there?
I would love to play with that stuff, but you know, I'm fresh out of that kind of hardware. It's not exactly easy to obtain that stuff. But no, VDI is a passion project of mine, and I would like the computer screen to come back. There we go. VDI is a passion project of mine, and I really do care a lot about this, and I have personal projects that I've been working on in Fedora for the past, I don't know, year and a half, about doing cloud workstations with KDE Plasma, working on improving the integration for that sort of thing. It's difficult because with NVIDIA specifically, your ability to multiplex the GPU is gated by the license that you have attached to your user space. And this makes it extremely complicated to test. I can't go get an RTX regular graphics card. God, I don't even know where I'm going to get one, because they're all, so either they're out of stock or extremely expensive. But even if I did get one, I can't use the functionality with it because it's gated behind what type of user space you use. You have to use the grid user space and the grid drivers. And those drivers are paired with specific graphics cards that I cannot get. So that makes it super hard for me to try. Now, that being said, would love for people to try out this combined with that user space and tell us whether it works or not, or if there's anything going on. Because like this kernel part should be the same for grid and non-grid drivers now, but
It could shift.
I don't have anything to test it with.
Excellent. Perfect. Thank you.
Any other questions? Oh yeah, this guy.
This is probably going to be an extremely naive question, but whenever a machine comes under my influence that has a NVIDIA driver, or NVIDIA card, I just throw it out and replace it with an AMD, and I just don't have issues like this. So why, again, my graphics requirements are pretty limited though too. As long as SuperTux card works, then I'm happy. And maybe
I mean, we definitely know SuperTux card works.
But is that not a solution in a broader sense for some people who don't really consider it?
Part of the driver for this comes down to two things. The first is in the mobile markets, laptops, handhelds, you can't replace the GPU. You're just stuck with it. And so there is no option to swap out from NVIDIA to AMD on there. So we need things to be working there. The second part of this is that unfortunately in life you have to make lemonade out of lemons. And the lemon in this case is CUDA. CUDA is only supported on NVIDIA GPUs, and there's a lot of workloads that rely on CUDA, specifically in video production, even AI/ML. Although AI/ML is getting better, they are now getting better support for all other hardware vendors, but especially with VFX, CG, all this other stuff where like you have to do post-processing works and you have compute shaders and stuff. A lot of it is written with CUDA programs, and CUDA programs are not portable to other hardware. And in the big enterprise spaces, or the graphic studios, or any of the people that would be here adjacent to the upcoming event SIGGRAPH, right, this is a primary concern for them because while I'm sure a lot of them would love to use something else, their tooling has to be adapted to work for other things. And it's a catch-22 problem. So the best we can do is try to at least make their lives a little easier with stuff like this. But if you have the option of choosing, if you don't have any of these constraints, by all means, that's a perfectly valid solution. This just helps out the people that it isn't an option for. Any other questions? Ah, guy in the back over there. Go, 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 Jonathan.
Thanks. Just to go back on the grid and the licensing issues and stuff like that. We work for Amazon Web Services, but I think all the three major cloud providers, their NVIDIA driver includes the grid license. So when you install their driver, however they make it available, you actually then get that vGPU, the grid license, as part of the driver when you install. So I can talk very confidently with AWS that that's exactly what we do. We do a cryptographic check that we're actually running that NVIDIA driver on an EC2 instance on our platform, and thus it essentially built within the NVIDIA driver that you download from our S3 bucket, which has already been qualified by NVIDIA. We also go through a qualification process internally in our team in Germany. That driver then provides you with a grid license, which then provides you with enough slots essentially to be able to run vGPU up to the level of limitation that that particular driver and or mashup of hardware actually allows, because obviously different generations of card provide different levels of slotting essentially on the vGPU. So maybe if people want to test, or there's those in this room that need access to, you know, an ever increasing different selection and generation of NVIDIA cards, and they don't want the complexity of going to NVIDIA and negotiating a grid license that bring your own license, BYOL. The point I'm trying to make is that, at least for us, that license is included in the driver, which is included in the cost of running that EC2 instance at, you know, per second on Linux, but basically per hour cost. Maybe we can look at supporting people in this room who actually need to do that qualification or need to do a bit more experimentation and testing, in which case, not sales pitch, but you should just come and talk to us.
Sure.
Maybe
talk to Jonathan right over there. He's the guy to get all this.
I'm not making any promises here, but I just wanted to clarify that kind of like that maybe might be an option if you're struggling, because like everybody is struggling to get access to GPU, right?
Yep.
For obvious reasons these days. But if you need to get access to that stuff to be able to look at what you can build in your own studios and, you know, and setups to have VDI options, to use fractional GPUs.
Yep.
We've just released a actual fractional GPU instance for this exact reason, because it allows you to drive down that cost. So yes, it delivers like, I don't know, 25% up to 50% kind of cost saving. That's great, but I actually think you could achieve even more if you could containerize more of your workloads, maybe also run some things as VMs as well. There's lots of options there that you should think about maybe playing with in the future. So just a whole bunch of ideas I'm just putting out there to the room really for people that I think there are options for experimentation here.
Yeah, there's definitely a lot of options here, and like if you're running unsecured container workloads, like as in Docker, Podman, or Kubernetes without micro VMs, then yeah, you don't need any of the multiplexing functionality. You get normal splitting through accessing the DRM device and time sharing it like you do on a normal Linux system, because it's just Linux processes. But yes, with micro VM type stuff, this would come into play, and then also there's grid licenses, fractional GPU things. we just don't have the ability to test all those things right now. We're actually working on ramping up, putting together a test matrix to qualify every time we update the driver. We make sure that we don't break it. And this is maybe this is something that we can talk to you guys about making sure we can cover that use case as well. As it is, like we can only cover what we have access to. So,
yeah, no, that's cool. And I mean, just as a reminder, there is quite a lot of performance degrade the more you essentially rely on the NVIDIA time slicing.
Yep.
Even with their best scheduler, you know, the moment you go from a half to, say, a quarter or a sixth or an eighth, there's some dramatic performance degrades of like 50% or more. So because if there's any workload that perhaps is video encode, very asynchronous, that amount of context switching, you will see quite a lot of performance degrade. But the thought I have, at least for this room on that front, is it depends.
Yep.
Your mileage may vary, and I think
it also depends on the criticality and the timeliness of your workloads, right? If you don't care about these things, then those hits don't matter. But if you do care, or if there's specific requirements or specific guarantees you have to have, then sure, you got to do it a little differently. But again, from this, that's, I mean, kind of a little bit out of scope of the thing that I'm doing here, but it's also relevant in the sense of like this is how you can consume it and leverage it. But we just don't have any. We don't have any tests for any of this stuff because we don't have the infrastructure for it yet.
Okay, cool.
Any other questions?
Just to add to that real quick, it is worth noting we are, we'll say, in talks with NVIDIA directly, trying to get access to more hardware so that we can do some more enablement things. And it's slow going, but it's going. So I would anticipate that more will be coming in the future as we get access to, you know, more hardware.
This guy had a question.
Yes.
Hi. Can you tell me more about the RFC approval? Just
Sure.
quickly.
Yeah.
I'm just curious.
So the RFC process is basically a way for people to propose a change or an improvement or an expansion of scope within the AlmaLinux project. In this case, because of the absolutely horrific experience that Jonathan and I had actually getting that System 76 machine working at scale, we decided that we wanted to fix this properly, or at least as properly as we can for Alma users. And we basically brainstormed on what the steps would be to resolve this to a sufficient fashion, and wrote it down and submitted it as a pull request to the Alesco GitHub repository. And there it was then open for comment, and then there were Alesco meetings about it. Alesco has a meeting every 2 weeks, and it was discussed a couple of times, and then once everybody felt like their understanding reached their satisfactory levels, it was voted on and it was approved based on the fact that everyone said it was a good idea to do it, and so we went and started working on it. And the first builds of that stuff was done like at the end of May, and we spent June and July refining it based on soak feedback and stuff like that, and then we had a very quick iteration cycle for all of that, culminating the release at like last week.
So more usable hardware, correct?
Yeah, I mean, so we've done this for a couple of other things. Like I think AlmaLinux that re-enabled a bunch of in-tree drivers that were disabled by Red Hat Enterprise Linux upstream. And that was also an example of one of those things that Alesco decided that this was okay to do. We've done this for things where we've deviated in the sense of like we pulled backports early from CentOS Stream into stable AlmaLinux. There's a bunch of different cases where this comes up, but you can basically think of this as when there is something that the community wants to do for the project from a technical or enablement perspective, it gets brought to either the board, Alesco, or the marketing team, depending on what scope it's in. And each of those groups has their way of determining whether this is something that we would go forward with. In Alesco, we have this review process with the request for comments, and we go from there and execute on it from there. And the board and other teams have different ones, but that's what Alesco does.
Okay, very excellent. Thank you.
I can add to that, just to add more context as well.
Sure.
So Alesco, if you're not familiar, is the AlmaLinux Engineering Steering Committee. And it was created after the most recent source code change that Red Hat did, the source code access change back in 2023. There's no point in Alesco before that because we were strictly just a one-to-one clone of Red Hat, or at least that's what we were attempting to do. With the source code change, when we started pulling a lot of our sources from CentOS Stream, it gave us the option to deviate in ways that don't break compatibility. And now, most of the time what that means is early security fixes, major bug fixes.
Additional features.
Additional features, which is what we're talking about in this case. So we can add things to the OS that don't break compatibility, you know, that maybe our users need, that Red Hat users don't need, you know, for whatever reason, they don't want to ship it, but we want to ship it to our users. So Alesco was essentially formed to be the oversight for the engineering within AlmaLinux. It's appointed by the board. The board is elected, and then Alesco is appointed members by the board. And it's to basically answer the questions of, you know, when somebody proposes a change, is this something that we can do? Can we maintain it? You know, is it for the betterment of AlmaLinux? Is it going to break compatibility? And ultimately, you know, should we do this? So that's really Alesco's primary role, is kind of facilitating those questions and those proposals and turning those into something that ends up in the operating system.